Point 2. Condition of air entering to the room. Condition of air entering to the room. Condition of air entering to the room, that is point 4. Point 4 is the supply point. Point 4, how we get point 4? T4 is how much? 0.6 of used air means 27 degree plus 0.4 of 19 degree. What do you get? Almost 24 degree or 23 point something. Okay. Okay. First point is over. Similarly, we get TW4. The first of all, mark T4 is 24 or 23 degree. So mark that point. 24, 23 degree. Therefore, suppose this is our point. This is our 4 point. Because this is a supply point to the supply point, that means point 4 is supply to the room. So the point 4 is intersect on the room sensible heat factor line. That is point 4. Okay. Similarly, we get T4, TW4, phi 4, omega 4. Okay. Point 2 is also over. Now calculate the point 3. Calculate the mass of fresh air entering to the cooler. Mass of fresh air entering to the cooler. That means mass flow rate of fresh air into your total room load by enthalpy drop. That means enthalpy drop is H3 minus H2. That means this and this. Okay. Room total load is, we have to now calculate this 51 point, already calculated 51.92 plus 23.1. This we get from psychometric chart. What is 0.3? T3 is 61. Sorry, H2 minus H3. H2 is 61 minus H3 is 49. We get from psychometry. What is mass flow rate is 6.25 kilo kg per second. Okay, kg per second. Now this is our third point. Now fourth point is calculate the bypass factor. Very simple. How we calculate this bypass factor? How we calculate the bypass factor? We already know this amount is x and this amount is 1 minus x. This is bypass factor, this is contact factor 1 minus x. Okay, 1 to 3, this is the contacting point, or 1 to ADP is non-contacting point, that is bypass factor. So BPF equals to T3 minus TADP of coil by T1 minus TADP of coil. Okay, T3 is given 19 degree, we TADP is 15 degree. This is given. T1 is 38 degree and this is 15 degree. That is 0.1174. Bypass factor is 0.174 or 179. Okay. Now last part is calculate the refrigerating load on the cooling coil. Calculate the refrigerating load on the cooling coil. So total refrigerating load equals to mass flow rate. Total refrigerating coil load is, this is the fresh air, that means mass flow rate of that fresh air into enthalpy drop between AC, that means H1 minus H3, because we have to calculate the load on the AC. So that enthalpy drop between AC into mass flow rate, that means H1 minus H3. Mass flow rate we calculate 6.25 kg per second into enthalpy drop. H1 is 85, H3 is 49 kilojoule per kg of dA. The kg cancel out, that means kilojoule per second. Kilojoule per second. Okay, how much amount? Kilojoule per second. Now first of all we calculate this. 6.25 into 85 minus 49. Value is, this value is 225 kilojoule per second. That means 225 kilowatt. Okay, 225 kilowatt. Now erase this. Very important point. I already told in our physical classes why the slightly variation of temperature does not affect the capacity of the AC or the ton of refrigeration or the load of the AC. Okay. First of all, 225 kilowatt is the capacity or refrigerating load on the AC. So how much amount of AC we require to maintain this configuration? Now we have to calculate the ton of AC. Which ton of AC is required for the to maintain this configuration for the hall type of room. Okay. First of all, we know 3.5 kilowatt equals to 1 ton of refrigeration. Okay. That means we divide this 3.5 kilowatt, we get TR, a ton of refrigeration. We divide this 225 kilowatt by 3.5. That means 64.2 kilowatt. Sorry, 64.2. Okay. Now, very important point is, if we go in the market, we cannot told the supplier or told the sellers, I have to buy 64.2 ton of AC. we go either 65 ton of AC or 63 ton of AC, which is available. Okay, we cannot told to the supplier we require 64.2 ton of AC. There is no configuration available in the market in fraction ton. Okay, 64.2 ton. We'll go for next slab or previous slab. Okay, which is available in our market. So the slightly variation of the tonnage or slightly variation of the temperature does not affect the ton of refrigeration. Okay, because if we take 27, if we take is here 29 degree centigrade maintained, or all the parameters are same, so we if we calculate this we get almost 65, 65 point something. Okay, but in the market, if we told the seller the available ton of AC is 68, okay, we'll go for 68. Or in the market is available 70 ton of AC or 60 ton of AC. In between 70 or 60, there is no availability of a tonnage of AC. So that if we calculate this 64.2 TR, we have to go for our next slab. Okay, that is 70 TR AC. So it is automatically adjust. It is automatically adjust all the internal variation of parameters, which is slightly above or little below our calculation. Okay, or slightly change in our calculation, it does not affect the tonnage of AC. Okay, thank you.